Welcome back, guys. I really hope you've been paying close attention because we are about to jump the shark. If you don't understand anything that we've gone up into this point, you are going to get lost very soon moving forward. So be close. If you want to go back and do previous videos, now's a good time to do it. I can wait. Okay, more seriously. Today we are going to be learning about classes and object-oriented programming. Up until now, almost everything we've been doing is procedural-based programming. That means everything happens one line at a time, and it just keeps on going and going, calling functions until it's over with. We've been using the concept of objects in the background, but we haven't really been making our own objects or doing anything with them. And today that changes. So, what is an object? An object is, well, it's a bit abstract and hard to say exactly, but anything in the memory that has properties and behavior is an object. I know that makes no bloody sense. Let's get some more meat on that, shall we? So, all of these are objects when they run. These are number objects. And this might be a function object. Right here, this is a function object. Here we have a string object. And if you recall down here below, we also have date objects. Like if I bring up the interpreter, and I say, let my date equals new date 11/14/1986. This my date is a date object. And objects, as you recall, have properties and methods. They have behavior. In this case, like I could say to JSON. What'll this do? I have no idea. That just prints out some string versions. So, let's see, to UTC string. All of these are methods of the date object. Or rather, I should say, they are methods of the date object's class. Now, I'm going to get started in converting this into a program that, rather than using all of these global variables for its storage, instead uses a class. So how is that going to work? Well, watch this. So first thing you need to know is, unlike functions, you can't declare a class just anywhere in this function. Classes you can declare all at the bottom if you want. Functions you can declare at the bottom if you want, but classes you must create them near the top if you want to use them further down. So we're going to create a new class. Class policy, and it's a code block, just like a while loop or anything else. The curly braces are the functions. Now, just like a function, it has these curly braces enclosing it, so everything inside of here is part of the class. But here's where it gets a little bit different. Classes can have their own functions, just like all of these down here, like .setDate, .getYear. Like if I do mydate.getYear, it'll 86. Just two. Wow, it only does 2 digits. That's kind of silly. Anyway, we can make our own. But first, each object, each class, needs what's called a constructor. A constructor is just like any other function, but the difference is that it's called automatically when this function, when this class is instantiated. Meaning created. Anytime you make a new policy, it'll call the constructor on that policy. And the policy needs a num, a first name, last name, birth date, due date, accidents. Notice I'm not going to put in age. So inside the constructor, we're going to use a new keyword, this. And this keyword only works inside of a class definition. So it basically means the properties of this specific policy. So when it creates, it's going to say this policy num equals policy num. That's basically taking whatever you passed it and assigning it to the object. This will make a little bit more sense shortly. This dot birth date equals birth date. This dot due date equals due date. This dot accidents equals accidents. So at that point, we can do this dot age equals lib dot calculate age. This dot birth date, because why calculate it twice? So, or actually, that would be stupid. Let's not do that, because depending on when we run the program, the guy's age may have changed, right? So we will make an age function that will return lib calculate age this dot birth date. Probably have no idea what I just did there. So, and we'll say name return this dot first name this dot last name. So you're probably pretty confused about what the heck I am doing here. Well, it's time to put it together. So let's actually make use of this. We'll clear out. Actually, we also need to put this premium in here. So premium, calculate premium can go. We'll just grab all of this right here and make calculating the premium a method of the insurance policy. So let premium equals base price, price base, and let total. We don't want to reuse the same thing over and over again. It's just bad practice. So this. So we're just going to change this to call this dot age. Actually, let's not do it like that, because if we were to do that, it would be running this calculation every single time. That's a waste of processing power. So let's instead do let age equals this dot age. Now we not only saved ourselves on typing, but we only ran the calculation once. So now we return total. So what does this accomplish? Well, you'll be seeing very shortly. Let me fix this. Not really sure why we're tracking due date, because nothing else uses it, or policy number for that matter. So let's actually do something with this now. Rather than calculate premium, we're going to display policies. That's not going to do us much good without an actual way to store them, so why don't we create a storage method for it. Kill this out. So let policies equal an array. Remember the arrays? We used them earlier. Don't need this either. So display policies for let policy of policies console.log policy. We'll just print out each policy that's been put into the system. Now get information. We'll make all of these local variables, because we got rid of the global one, so we can't use that. And now we're going to do something a little bit different. We're going to create a new policy object using this constructor. So how do we do that? Well, we'll use let policy to create a local policy only to this function equals new policy. Notice the difference between the lowercase and the uppercase. Here we're getting the uppercase version, which has, you'll see it's already detected our arguments. So it wants the policy number, first name, last name, birth date, due date, and accidents. If that's all we did, it would just fly in the middle of space and not go anywhere. We want to actually store it somewhere. So we'll say policies, that being our array we just made, push policy. And that should actually be that. So I'll just get rid of this display totals, because we'll just display totals. Actually, we'll just do it like this. For let policy of policies, console.log total for policy.name policy.premium. So we're going to call that premium method on this and display the output of each one. So what's going to happen when we run this? Let's find out. I think it'll work. So calculate premium. Oh wait, I made a small mistake. Oh no, I didn't, never mind. Okay. So calculate premium, and I'll put in number 1. I'm Andrew Bastian, 11/14/1986. I boo-booed. Fixed. Okay. So total for Andrew Bastian is 210. That's running right here. Now, I could have sworn it was gonna... Why isn't it display policies for let policy of policies console.log policy? Oh, it only does it when I do display 1. Okay, I see. So calculate program. You'll notice it's printing out this policy object, which has policy num1, my name, birth date, due date. This is how it's displayed internally. It's just rendering it to this to make it easier for us to read. So if I make in a policy number 2, Wyatt Youngs, and I'll use my same information because I don't really care about what all this is. 2000 and 02/02/2020. Now if I do, now notice it's printing out 2 of them. We have reused almost all of that code to make 2 different instances of policy. Each one has its own policy name. If I bring up 1, you'll see now we have 2 different copies of policy. We have 1 here and 1 here. Each has a different policy num, different first name, different last name, different dates, different everything. So this is code encapsulation, the very basics of it. Also, object-oriented programming. We have created a policy object to represent our information and our methodology of how the information is to be used. I hope you're still with me, because it gets crazier from here on out. See you next video.